Hello, everyone. Let's wait for a few more minutes to wait for speaker to join. And so today we will gonna be it's a workshop, and you will get started with AWS. But if you want to hands-on in this workshop, I do recommend you to go to the AWS to set up an account. So let me share the uh, link in the chat. So basically, if you don't have a AWS account, and you can just complete a setup by go to the aws.amazon.com and you click complete setup. So you can create a new AWS account. Yeah, it's will be free, and there will be free tiers, and also it do require you to input your credit cards. So but they don't charge you if you pick the free, like a trial free service, and it's totally free. So what we're gonna do is simply put your user email address, and then click verify your email address. You will receive a code to activate your account, but you will need to input your credit card information. But again, they're not gonna charge you for anything, and they just use that for the reference. And if you already have an account, but your account already expired for 1 year free trial, you can create another email account to follow on to repeat this progress. So I do recommend everyone. Again, let me share the link again. So it's aws .amazon.com to set up account. And if you have any question during the setup of the account, you can let me know. Okay, so for the audience who just joined, so let me share the link. You do need to set up your AWS account, and it's totally free. And as long as you don't pick the pay service, it's totally free. So after you log into the, after you go to this website, I share in the chat, and you can click on the right top corners. You will see there is a complete sign up. So you can click complete sign up, and also there at the very bottom there will be an option for you to create a new AWS account. So once you click that icons, and you just need to input your emails, and also you also need to put account names, and also you click verify your email address, right? So you will receive a link from AWS, and follow the instruction or the link to set up your AWS account. So if you have any question during this progress, you can also let me know. Okay?
Hey everyone, thanks for joining this session. We will be talking about, so for this session, we'll be having a quick introduction to Amazon Web Services. So if you have any questions along the way, feel free to ask. Adam just introduced how to set up an account on AWS. If you haven't, feel free to do that. You can do that after this session as well. Today, I will give you a high-level walkthrough of Amazon Web Services and do some demo to help you understand how it works. But yeah, before we get started, I just want to explain like why we even use cloud. What's the benefit of using cloud? I'm sure you have some experience, or some of you may have been working with AWS already. So if you have any comments, please feel free to unmute yourself, let us know, or send your your comments to Zoom chat or YouTube as well. I guess this is my question to you. Why do you think we even need cloud? How does that compare to on-premise services? Because if you don't use cloud, then you run everything on your local computer or on your own infrastructure, right? Anyone?
Well, I could say or assume, based on personal experience of working as a network administrator in data centers, that when we wanted to launch a new service, it took us a heck of a time to wait for the payment cycle in order to purchase the new equipment and then install and then test and then launch, etc., etc., etc. Plus, we had to pay lots of money to maintain an infrastructure that would cover our future needs that wasn't necessarily needed at the moment when we launched the project or the product. So I guess the cloud could solve such a question concerned to costs and scalability.
That's
I've never worked with
yeah.
clouds before, but this is based on real physical experience in physical data centers.
That's spot on. Yeah, that's one of the primary reasons I think some companies will choose cloud. Not for every company, but yeah, I agree. I used to work for tech companies, and if you want to launch, I remember that was 10 years ago. We were trying to access, Apache Spark and Hadoop clusters. But I work in the data science and engineering team. You don't just, go get your own infrastructure. You have to wait for your dev or infrastructure or platform engineering team in IT to go through this whole planning, phase. It might take months. So it took us like 6 months talking to different vendors, and it's a serious investment, not just money, but also time and planning. But then the moment you get it, maybe there's something new out there. So I think managing your own is definitely challenging, and you need a lot of expertise as well. So getting started on the cloud, it's very easy. It's quick. So I think it will make sense for some of the larger institutions to still have on-prem services, or they have both, right? They have a hybrid approach because for some industries are heavily regulated, and they probably don't want you to put everything on the cloud. Reliability is also a concern sometimes. So there's some workload running on-prem, but most of the company will have legacy systems as well. So even though they're gradually, migrating to the cloud, but for a startup, right, that's just getting started, it makes total sense for them to just go with cloud because you just put in your credit card, and then you can start right away. If you want to build, a small data warehouse, or you want to, do something serverless, it's pay as you go. So you can get started so much faster. So the agility, right, is what people want when it comes to cloud. But I guess as you grow, when you truly have like a ton of customers and a lot of a lot of data, I've seen people saying that they're actually going back from AWS to going back to on-prem, because once you get locked into cloud, there are all kinds of costs associated with it, hidden costs as well. But that's a separate discussion, I guess. So there are lots of good reasons. For example, right now, you're seeing my AWS, account. You'll be able to see the bills, right, and where we spent the money on a monthly basis. But I think transparency, is also something really nice about cloud. If you are managing the cloud infrastructure for your company, then they show you very detailed, billing details, down to, each individual service in different regions. So you know exactly where you spent your money. So you can optimize the cost, right? So that is a very important reason to consider using cloud as well. But you know what? Let's continue. I think we're talking about the cost and usage. So AWS give you a lot of control on how you actually understand the billing. I think that's very, very important because that helps you understand how you can optimize the cost, right? So that's another good reason to consider using cloud. And there are some other benefits as well, of course. So that's why we should consider using cloud. Now, the next thing I would like to help everyone understand is that when we are talking about cloud, some companies are talking about infrastructure, but sometimes you're talking about a managed service, and sometimes you're just talking about a SaaS software that's provided by cloud as well. So, does anyone know the difference between IaaS, which is short for infrastructure as a service, and PaaS, and also SaaS. Does anyone know what is infrastructure as a service? So basically, IaaS, here's an analogy. Like, let's say, if you would like to eat pizza, let's say for dinner, IaaS basic means that you need to, have, for example, have the oven yourself. You need to buy all the ingredients yourself and know how to cook a pizza and make a pizza dough, and how to cook it yourself. Right, but you need to have the oven that you need to cook it as well. That's infrastructure as a service. If a company would like to build their data pipelines in the cloud and build data warehouse or build AI applications, then they need infrastructure. At the bare minimum, you need some servers, right? And the servers need to be connected to the web. So you need networking. You need storage, right? Data will need to be stored as well. You need databases. So if you are building all of these yourself, right, it's basically on-premise. You probably need to manage your own data center. But if we outsource this to the cloud, so we're using AWS basically as infrastructure as a service. So you get the core services from Amazon, such as networking, VPCs, EC2 instance, right, where you can run servers in the cloud. You can use S3 for data storage, and then once you get access to these core services, you can build everything from there. So it's basically just moving whatever you do on premise to the cloud, but you're still going to manage everything yourself. And that's infrastructure as a service. And a lot of companies, large tech companies, they probably go down this route. For example, when Netflix, right, built maybe their recommender systems, and they are going to use Hadoop and Apache Spark to store and process all of their big data. It's part of their stack. And they may actually prefer to run Hadoop and Spark clusters themselves, working with the pure open source tools instead of using the managed service. Well, if on AWS, they also have managed services such as Redshift, right, which is managed data warehouse tool. I think it's the very first cloud data warehouse tool, and it's competing against Snowflake and Google BigQuery. And if you want to work on big data, Amazon has Elastic MapReduce service. So that's the managed Hadoop and Spark cluster. So the difference between PaaS and IaaS is that if you go down the IaaS path, then you're just going to get those servers, and you need to install Hadoop and Spark and all of those database systems yourself, right? And you manage them yourself. But when you work with platform as a service, and launching a Hadoop cluster basically just becomes some sort of, you have some template, you're going to do configuration. Amazon Web Services is going to manage all of these for you. So things become a lot easier when you start to work with platform as a service, or in Amazon, some of these are called managed services, right? But of course, there's a cost associated with it. Because EMR, Redshift, they are running on the core services such as EC2, right? They use S3 to manage storage as well. So you need to pay the EC2, right? The server cost. You need to, pay the storage, cost, but you need to pay the management fees as well, because they're, making your life a lot easier. So that's platform as a service. Well, as a platform as a service, right? You still need to cook yourself, right? And for example, you're buying, frozen pizza. You come home, right? You still need to microwave it, right? It doesn't mean you don't need to do anything, right? So so if you're using Amazon SageMaker as a managed machine learning service, your data scientist will still need to write machine learning model training pipelines, right? It doesn't provide the model for you. It provides the ML, infrastructure and platform for you, so that you can actually use that to scale your ML pipelines, but you still need to know how to build machine learning models, right? SaaS, we're using SaaS a lot of SaaS software, on a daily basis, right? Like your Gmail, Facebook, Twitter, all of these are SaaS, software as a service. And in the AWS ecosystem, it could be something like, recognition. I think there's a service called recognition. So basically, they're pre-trained models, right? You don't need to be machine learning expert. You just need to upload an image, and it will do object detection, image classification for you. So they provide pre-trained models, and it just uses as is. You just need to provide the data input, and you expect to get some sort of output. So that's SaaS. So IaaS, PaaS, and SaaS. So let me give you a quick walkthrough of some of the AWS services. If you log into AWS, there's an option for you to see all the services in the console. They break it down by different categories, right? There's the compute service. There will be machine learning service, containers, storage, databases. A lot of these are managed services, and some of these are the core, the infrastructure services. Okay. Well, I'll go through a few of these. So let's start from IaaS. Let's say EC2, which is short for Elastic Compute. It basically allows you to run servers and instances in the cloud. You can use a template to launch EC2 instances, but you can use the Python API. You can use Terraform, or even just launch the instance manually step by step, right? So they give you the instructions. You need to choose the instance type to launch an instance. For example, let's say demo. Let's launch a demo instance, right? You need to choose your AMI. That's like the operating system. You need to choose an image. So let's say we go with Amazon Linux, and you choose the AMI, just different distributions, and then you can choose the instance type. Of course, you can choose the architecture. So you just need to do this kind of configurations, right? Instance type. T2 Micro is one instance type that's free for the first year. I have my account like longer than 1 year, so it's free. I can't use it for free anymore. But yeah, there are many different types of instances. You're essentially just getting the resource from AWS. I think some instances, can be as big as 1 to 2 terabyte of RAM. So if you prefer to run R instead of Spark for machine learning, you want to run everything on one single instance, then you can launch like an instance that has 2 terabyte of RAM. That solves most of your challenges, and R can run very fast on the machine as long as you have enough memory, right? But it doesn't solve all of your problem, because sometimes the challenge is the data is too big. It doesn't fit. Like, what if the data is bigger than 2 terabyte? Then you have to go with distributed systems and things like that. But just so you know, they have very different types of instances, and some of those are built for machine learning and AI, GPU instances. But some of those are optimized for compute on CPU, so you can use that for data pipelines. So you just need to choose the instance type, right, and then choose key pair. Key pair is for someone who want to sort of log into like a remote instance, like through SSH, right? And you can choose to launch it without a key pair. So in that case, you will not be able to connect to the remote, but then you can probably use the web console. And then you choose the networking. I won't go through all of these in details, but just so you know, this is how you config an instance when you launch it. There's so you can add more storage, right? How much storage you need for your instance type, and it can there are more fine-grained controls here, but you can put all of these in a template, right, and use Terraform to launch the instance you need, so you can do infrastructure as code automation. Okay, so that's EC2. Let's go back and take a look at some other services. So in the compute category, I would highly recommend looking into Lambda as well. So The difference between EC2 and Lambda is that Lambda is serverless. So you only get charged for the duration that you run the compute. But EC2 instance, usually when you launch it, you'll get charged for a minimum of 1 hour. They charge you like by hour. So it's like 20 cents per hour for one type of instance, right? And you can use spot instance as well to save cost. But Lambda is different. It's designed for a different kind of workload, right? So if you don't, you're launching a web application, but people don't use the service very often. They come, the traffic come periodically. Then you can maybe leverage Lambda, and you can significantly save cost. If there are only 50 API calls, in an hour, why would you need a server dedicated for that? Maybe you can just, call Lambda functions. So Lambda is very powerful, and some companies will build serverless pipelines, and you can use it for not only data transformations, but you can use it in some of your real-time systems as well. So that's compute. And let's move on to storage. Storage is the backbone service as well, right? So you want to, and it's object storage, so you can use it to store any type of, data, whether it's text, right, images, videos, movies. I think when you use some of the social media apps such as Instagram, and you're checking out someone's profiles and pictures, that picture is stored in S3, and each picture is considered as an object. It has an HTTPs, right, URI, and you can just download the images directly from S3. And then of course you need to have a NoSQL database or relational database that just manages the linkage between the database object and the actual storage location in S3. S3 is great for keeping some of the frequently used data, right? So when you ingest your application data, server logs, you can ingest them into, or when you do migration from on-prem to cloud, S3 is the perfect place for landing all of these data. So the typical usage pattern of S3 is that you use that as the landing zone, like landing place. So there's a landing zone, and then that's where you keep all the raw data. And then you build the data catalogs, and you can use different services to directly access the data stored in S3. And if you're building data pipelines, ETL, so you can actually create an intermediate stage where you keep all the intermediate data. Eventually, you're going to load that into the warehouse, or some companies directly build data lake on top of S3 as well. But if you have data that you want to archive, right, for the long term, you don't need those, in your daily data analysis or whatever in your applications. And then you can archive those data in S3 Glacier. That's a service that's a lot cheaper to store all of those historical data. But the trade-off here is that, well, it's cheap, but when you need to access the data, you don't get access to it right away. It may take you minutes, half an hour or even hours to get those data back. And then you're going to load it back to S3, and then you can access those data. And then you can set up intelligent tiering, which means that you can sort of have some sort of policies, as soon as the data hits like 6 months, and then you can automatically archive the data. So yeah, it's pretty powerful, and then you can have very fine grained control over what data you're going to share, whether you're going to encrypt the data or not. So these are the different options offered. Okay, so that's storage. So compute and storage, once you have that, and along with the VPCs and all the networking stuff, you can build any kind of applications you want in the cloud. So companies use these as the infrastructure backbone to build their applications. Right now, let's move on to platform as a service, right? Because not every team are experts in infrastructure. Like managing these servers do require expert knowledge. It's launching an EC2 instance is easy, but you still need to maintain all of these, right? And installing all the software and stuff. So there are teams, right, that are just getting started. Let's say startup. They probably wouldn't spend whatever money they got from the investors, angel investors, on hiring an IT expert to help them manage the infrastructure, because they're not even there yet. Their priority is to build their core services and product, right? Writing code, even just on their own laptop, and build MVP to get more investment or start to get their first customer. So they're not going to get a lot of traffic on their So in that case, I think hiring a software engineer who not necessarily specialize in infrastructure, that's the priority, and then they just want to move fast. So in that case, and if you want to, deploy your applications in the web, you can use Beanstalk. There are other options as well. If you do need to train machine learning models, you can leverage SageMaker, which is a managed service. This is platform as a service. Again, if you're launching a startup, you're not going to use like a SaaS software. All you need is, even if your company is building LLM services on top of OpenAI, you still need people who can code and build applications, right? So you're still going to be able to need to write your own code, right? So, but you don't want to worry about installing other software and deployment stuff. So in that case, use managed service, right? So SageMaker is platform as a service. If your company do need to build a data warehouse, or build that for your clients, then you can leverage, Amazon Redshift. It's under analytics now. It used to be under databases, but yeah, Amazon Redshift is managed cloud data warehouse, which, if you want to build a search engine, then you can use the OpenSearch services, which is, I think, based on Elasticsearch. And they also have managed, Kafka services and Kinesis, which is kind of similar if you want to do, streaming data analysis and use that as a distributed messaging queue. So you don't need to be expert in managing the Kafka cluster, but you become a user, right? And you'll focus on actually building the application. So that's the beauty of managed services. And I'll just give you one example. I'll walk you through SageMaker. SageMaker is Amazon's managed machine learning, service, right? So it's pretty powerful and end-to-end. You can use it, for example, I think a typical machine learning lifecycle starts from data labeling, right? So if you want to label data and you have, let's say, 1 million images, you want to train computer vision models. So in that case, you may want to label the data yourself. But doing that manually is too crazy, and you need to hire a lot of people and manage that. So you can leverage a third-party service like, SageMaker. I think it's based on the Amazon Mechanical Turk service, right? So when you create a labeling job, you just need to create the job name, and then in the task type, right, you can choose whether you want to label images or text. And then you choose the type of labeling services you need, right? And you need to create a template that has some sort of instruction, because those are remote workers who help you label your data. There are some standard template that you can use to sort of teach people how you want them to label your data. So you do need to give some instructions. And then you can upload the CSV file to the cloud, and people will start to pick up those tasks because they get paid for each task they complete. I think the average cost is about $6 to $9 per hour, US dollar. And then you can get your data labeled quickly. Unfortunately, it doesn't have everything you need. So for more specialized, data labeling and annotation, you might want to work with some, third-party companies such as there are labeling services out there that are more specialized, right? But this allows you to sort of do all the data annotation. That's the first step in your machine learning pipeline, right? And once you get your data labeled, if you want to build like just a quick, dirty model, right, simple classification model, you can even use the SageMaker Canvas, which is a no-code machine learning tool, and it has, I think, text analysis. It supports LLMs as well. But you don't need to be a data scientist to use this tool. But if you're a data scientist, the first step might be, doing data wrangling, right? So you can open the SageMaker Studio, but this might take 10 minutes to launch. But you can open SageMaker Studio that has a Jupyter server, and you can use the data wrangler service to prepare data and build the data transformation pipeline. And once the data is prepared, you can use the SageMaker Notebook service to start, writing the code to train your machine learning models. So you can go to Notebook instance, and you can create a Notebook instance, and that gives you access to Jupyter Lab, and that's where you build the models. But but that's not how you train the model, because when you launch a single notebook instance, right, it allows you to, it's a relatively small instance where you can actually write the code and do visualization, data exploration. Imagine your data is really big. You want to do distributed model training and distributed parameter tuning. In that case, you can use the training service. It has support for, you can bring your own, algorithms, containerized algorithms. Amazon has a list of, available algorithms as well. So you can just write Python code and, call the training jobs, and it will, train the models at scale. And once the model is trained, right, it gives you the options to sort of deploy the models. You have different deploy the models as prediction endpoints. They have pipeline services that allows you to build machine learning models end to end. So that's a managed service, like, because if you are a data scientist and if you want to do something end to end, labeling data, wrangling data, and maybe you have big data and then you want to train your models on a cluster, on a Spark cluster, I think you end up wasting a lot of time just figuring out how to set up the environment, and you have to maintain that. So that's very painful. And a managed service will sort of take away those, those concerns, and you can just focus on coding and building your machine learning models and AI solutions. And it has pretty strong MLOps capability as well. So that's SageMaker, managed services. And in terms of SaaS, I'll give you one example. For example, the recognition service. So they have pre-built or pre-trained models where or if you want to use AWS Transcribe to transcribe all the videos and audios you have. So they have pre-trained models that you can just leverage that as an API. So you don't need to know how to train these AI models. You just need to use that as a service, right? So they have an API where you can upload data in batch or in real time, and you get the prediction back. So in this case, you can just upload an image, right? And then it will automatically help you, generate predictions. But these are pre-trained models. So that's one example of a SaaS software in the service provided by AWS. Do you guys have any questions so far? If you have any questions, feel free to send that to Zoom chat. I'm happy to answer your questions. There was a question from Larry. How are the AWS SaaS different or same as Hugging Face? I think Hugging Face is a library, that for you to have access to different kind of models, right? So most of the LLMs, or cutting edge algorithms, when they get open source, it will be available in Hugging Face like really quickly. And then you can use the Hugging Face libraries to load those models. So you can start using those open source models right away. But it also provides the capability to fine tune these models. But Hugging Face doesn't really take care of any infrastructure. I don't think company will be running production code on Hugging Face. Correct me if I'm wrong. But AWS SaaS, you call that as a API, right? So you're basically working with an existing solution. AWS has transcribe service. So if you want to transcribe a video, you can just call the transcribe service, right? If you want, they have like fraud detector services and even pre-built forecasting models that you can use. So you just need to upload the data and it will just train the forecasting models for you. You can do translation as well. But Hugging Face, they provide these models, and you will still need your data scientists to use those, the models to train your own model, to apply that to your data. For building an end-to-end personal DS project, what services in AWS are particularly useful? I think if you want to build a data science portfolio project, I would recommend a few things. So first of all, definitely try to work with the SageMaker service. But you don't just use SageMaker to train a scikit-learn model. Like try to use, if you use SageMaker, try to build something end to end. For example, you can use SageMaker to label the data, right? And then you can use SageMaker to train the models, but also try to deploy the models. And so you built something end to end. That could be one project, which is, ML pipelines on SageMaker. But I think it would be also interesting to build something that has, data processing and data ingestion. So for example, you can use the Kinesis service. And you can that to create data streams. Let's say your application is real-time fraud detection, or you want to do some sort of real-time sentiment analysis, right? So you're going to launch an EC2 instance and use that as the producer to read data from API in real time and ingest that into Kinesis data streams, or we can use Firehose service as well. So that means you need to have a pre-trained models, right? Using scikit-learn or whatever libraries. You can do that in SageMaker as well. And as the data comes through the data streams in Kinesis, we can use the pre-trained models to do real-time prediction. So that means you can deploy your models in the Lambda function. So data streams will send the data to Lambda function as a trigger, and Lambda will basically generate real-time prediction. And then you need to decide how you want to leverage the prediction, right? But in practice, if you want to do some sort of fraud detection, or you need to basically maybe consider using the Firehose service, because it will, you can choose the destination to be an HTTPS endpoint, where it's another software that actually write that prediction somewhere in some other systems, where an agent will be able to see an alert on the dashboard where they can actually look into those cases, right? If it's fraud detection. So try to build something end to end, so data ingestion, and you have pre-trained models, and you can see if you can build some interesting applications. That could be another interesting use case. Or the third option is you go with work with the EMR service if you want to showcase your it's EMR. Okay, the EMR service. Launch a Spark cluster, and you use that to handle large data set. So there are some open, public like open big data set on Amazon, right? See if you can use Spark to process those data. I think that would be impressive as well. Which one do you prefer between AWS and Azure in terms of price and services? I think there's always a price war. I don't think the cost will differ that much for your own use cases. My personal experience, I'm more leaning towards Amazon Web Services. I think it's mainly because I just started my cloud journey with Amazon Web Services. I've worked on projects leveraging Azure, but maybe I just enjoy more control, I guess, and more flexibility, and maybe just because I'm more familiar with AWS. Yeah, so I like to work with AWS better. Did some pretty big project in Azure, but it's pretty good. A lot of big companies will prefer to work with Azure as well. But yeah, I personally favor Amazon Web Services. Is it true that if you grasp the cloud technology knowledge itself from AWS, then it's easy to switch to other vendors, since the difference is going to be only how to do vendors brand their services name commercially? Yeah, I would agree with you. I think if you want to break into this industry, right, I wouldn't recommend you spending effort on learning all three clouds. I think you should just focus on one and get really good at it. And then it shouldn't be that hard for you to switch from Amazon Web Services to Google Cloud or to Azure later. And unless, right, the jobs, because there's sometimes recruiters will be helping companies to hire specialists, and they would prefer the candidate to be specialized or certified in Azure or Google Cloud. So they're looking for specialists or maybe cloud architect. So in that case, then you do need to have like very strong knowledge in one cloud, right? But switching from one to another, it takes some time for you to grasp new concepts and new tools. But I think the core concepts and skill set will be the same. So that shouldn't be that hard for you to switch. What AWS related jobs or skills do you see to be in demand? Yeah, that's a very good question. So people learn and use AWS in different ways. If your passion is to become a data scientist and data engineer, then I think you should be focusing on the data part, right? So for example, when you work as a data scientist, even if you're using Amazon Web Services, most likely you'll be working with managed services like SageMaker, or your company have helped you set up your Jupyter Notebook, GPU instances on EC2 instance. So you'll just be accessing those, right, through a web portal or whatever, Jupyter Notebook, and you start building a model. So the most important stuff you do as a data scientist is still writing code, analyze data, train models, right? That has nothing to do with cloud. However, when you want to start deploying the models, so you work as like machine learning engineer or MLOps, that does touch on more like infrastructure stuff, because you might need to be familiar with CI/CD pipelines, right? So AWS has code deploy and similar, like services similar to GitHub Actions, for example, right? Or Jenkins. So you do need to have knowledge if that's what you're going to do. But if you need to containerize your machine learning models, then you work with Docker, right? So you don't really need to, that doesn't depend on AWS. And AWS has ECS, ECR, EKS, right? Different, even Fargate. But at its core, you containerize your application. When you deploy them, maybe you deploy that to, a different type of AWS services. There are different ways to orchestrate containers, right? So having a bit knowledge about ECS, Lambda, all of those will be helpful. But only knowing those doesn't help you become a data scientist. So all I'm saying is, if you want to become a data scientist, the way you learn cloud will be very different from the way you learn cloud as a cloud engineer, right? So you still need to focus on data analysis. And just like data engineers, you need to focus on the open source tools and how to build data pipelines, and most importantly, how to transform data, right? And then you're using cloud as a service. So that part is not hard. It's just days and weeks for you to pick up all of these. You can even learn that on the fly, right? But having those experiences on your resume will definitely help you enrich the resume and give you more, advantage. However, if you want to become a cloud engineer, which is very hot right now, then if you want to focus on AWS, then the companies might be looking for someone who's specialized in AWS technologies, right? Then you need to know the nitty-gritties of AWS. Then you're not going to worry too much about working with Jupyter notebooks, but you need to know all of these services, and especially things on governance, security, right, networking, and how to work with different types of services. If you're building data practice, then understanding data catalogs and governance, these are all very important. So that's something you need to focus on if you want to work as a cloud engineer. But yeah, in terms of what's in demand, cloud engineer, absolutely in demand. Data engineering, that's why you see the cloud providers are also offering data engineering certification, because some companies might be building all of their data pipelines in AWS cloud. Then you need to know how AWS provides services to do data cataloging, how to manage the security and all of those, right? And how AWS run, let's say, Redshift as a managed, data warehouse tool, So yeah, cloud, I guess, AWS data engineer or Azure data engineer, these will be in demand. And of course, data scientists, I think the cloud, which cloud you work with is not that important. I think it's you just need to be familiar with them and know how to use it. That's good enough. And as MLOps or ML engineer, some companies would like they go with the Google stack. So GCP, Vertex AI. They may prefer you to know how Vertex AI work, but honestly, if you come from SageMaker background, and it's very easy for you to switch to Vertex AI, and you're not going to get hired as an AI engineer only because you know more about Vertex AI. You definitely get hired because you know how to build models. So cloud skills are definitely nice to have. It helps you build more powerful portfolio projects. That's my 2 cents on this. Any other questions? Sorry, the presentation got a bit interrupted today at the very beginning. I couldn't do all the demo I want to, but hopefully that sort of give you a quick intro to different kind of services of that's provided available in Amazon Web Services, and we can have a follow-up session in the future to dive deeper into some specific services such as SageMaker or Athena or maybe Kinesis. Another suggestion I have is that if you work as a data scientist, some students will ask us like, do I need to get certification? AWS has a machine learning certification. It's mostly multiple choice questions. Yeah, I don't think it's going to add that much value if you're just looking for job. Because I don't because knowing how to do multiple choice question doesn't mean that you can you can build machine learning models really well. So that's very different. So I haven't seen like employers emphasizing too much on this, like say, oh, you need to have a machine learning certification in order to become a data scientist or get hired. People care more about whether you can actually do things. So they will give you a take-home assignment and see, they would prefer to look at your code or the type of projects you have built in the past. But if you want to become a cloud engineer, I think getting certified is absolutely critical. So you need to start with the developer associate, and then move on to the solution architect associate certification. I think maybe getting certified as a data engineer can also be helpful because it does require you to be familiar with many different services. Yeah. Do you mainly specialize in data science, engineering related services, or could you also do a more in-depth overview of infrastructure related services? Yeah, I'm more specialized in data science and engineering and AI. If you prefer like an in-depth overview of infrastructure as code, we can invite some other speakers to do this in the future as well. I can hack my way around, but definitely not expert on infrastructure. All right, I think that's it for today's session. Thank you very much for taking the time to join this session. I hope this is useful, and look forward to seeing you guys in future events. Thank you very much.